What's up, everyone? Today we are going to solve quadratic equations by factoring and using the zero product property. So this is the third method of solving quadratics that we've talked about. First, we looked at solving by graphing, then solving by square roots, and now we're going to talk about solving by factoring. So we were looking at solving by square roots because that was the kind of the intuitive way to solve, right? Square rooting is the inverse operation of squaring, but we talked about how if there's that pesky linear term, like thinking about in ax squared plus bx plus c, that standard form, then we can't use square roots to solve. So what do we do? Well, our next option is if I could factor this so that I had two factors written as a product, then I would be able to solve that way. So what we're going to do before we get started is a little investigation. So I want you to go ahead and find three solutions for sum number A times sum number B equals 0. Now this is a bit open-ended, right? But I want you to come up with as distinct as you can three different possibilities, and then we'll talk about it. All right, so like I said, lots of right answers here. I don't expect your answers to necessarily match mine, but the first one I did was I said, well, 0 times 394, that's 0. All right, next I just said, well, 8 times 0, that's 0. And then my third case was, well, what if everything was 0? 0 times 0, that's 0 too. All right, and so what hopefully you discovered is that either A or B or both, right, had to be equal to 0 to be able to get this product of 0. So that's what we call this zero product property. So if I have some A times B, and that's equal to 0, then A equals 0, B equals 0, or both of them equal 0. And it's this fact that we're going to use to be able to solve by factoring, because if I can rewrite, let's say I end up with some factored form, x plus p, x plus q, right, then I could set each of those factors equal to 0 using this product property. All right, so here are our steps. First, we're going to write our equation in standard form and have it set equal to 0. It is the zero property, or the zero product property, not the two product property, not the four product property. These are jokes that I tell in my class that I probably get the same amount of laughs as talking to myself right now. Anyways, it's gotta be set equal to 0. We want it to be in the standard form because then that's where we are trying to factor from. So next step is going to be to factor the quadratic expression. And then we'll set each factor equal to 0 and solve. All right, so this right here kind of left for you is a great spot to maybe put some of your favorite factoring practice if you would like, or maybe some reminders about factoring. But yeah, so let's just see really quick what that would look like if, oh, here, this is what we'll use this space for. If I had some x plus p, x plus q, I set that equal to 0. What this would look like is I'd take this factor, x plus p, and set it equal to 0. And I'd take this factor, x plus q, and I'd set that equal to 0. and then I'd have to solve. All right, so over here, right, that might look like subtracting P. Over here, that might look like subtracting Q. Alrighty, so let's look at an actual problem. First things first, I've got this nice A is 1 factoring situation, so it's already in standard form, so that equal to 0, so we got that taken care of. I'm thinking about factors of 21 that are going to add to 10, and so that is going to be plus 3 and plus 7. All right. So now I'm going to set each of those equal to 0. So I'll have x plus 3 gets that equal to 0, and x plus 7 gets that equal to 0. Then we'll solve. So here, these are one-step equations, so I just have 2, take 3 away, and I'll get x's minus 3. It's my first solution. Here I'll subtract 7 from both sides, and I'll get x's minus 7 as my second solution. All right, so we're looking for factors of 12 that add to negative 7. So x is minus 3, x is minus 4 equals 0. All right, so same thing. We're going to set this factor equal to 0. We're going to set this factor equal to 0. So I'll end up with x is positive 3 and x is positive 4. All right, this next one always trips my kiddos up, but because there's no C term, we can factor out x, and this is our factored form here. We have x times x minus 1. So x here is one of our factors. We set it equal to 0, and it gives us the solution. We don't have to do anything else to solve. And then we'll have x minus 1 equals 0. And so x equals 0 is one of our solutions. And then here we just add 1 to both sides, and we get x is 1 as our solution. All right, now this lesson is not a primer on factoring by any stretch of the means. So you can check out some of my other videos. I do go more in depth in factoring in other places. If you're like, dude, I totally could use a refresher because I understand. All right, so now let's go ahead and look at example 2. So starting to get into a little bit more technical factoring. So not too bad. So this first one here, we have to add this 7x to both sides so that this is set equal to 0. So I'll have 2x squared plus 7x plus 3. All right, so here we're thinking about factors of, right, 2 times 3 or 6 that you're going to add to 7. Or if you don't want to think about factoring it that longer way, 2 and 3 are both prime. So we know that the only way that we can get those is by multiplying them by 1. So for example, the only way to get 2x squared is to do 2x times x. And then the only way to get 3 is going to be 3 times 1. In here, 3 multiplied by 2x is going to get me 6x, and this will get me 1x. So when we add that together, that's like got 7x in the middle. Our signs are positive. I just thought that I wasn't going to help you too much with the factoring, but can't help myself, I guess. All right, so now we're going to set each one of those factors equal to 0. So I'll have 2x plus 1 equals 0. Now that's a two-step equation. All the ones we've had before have been one-step equations, but that's okay. We know what we're doing when it comes to solving linear equations, right? So this one's going to be x is negative a half, right? I subtracted 1 and divided by 2. And then we had x is going to be negative 3 here. Here, notice there's no linear term, so we could totally solve this with square roots, but I did want to see what this would look like with factoring. So if first I take out that GCF, I'm going to have 2 times x squared minus 16 equals 0. And I'm going to factor that as a difference of squares. So factors is x minus 4, x plus 4. Now, 2 technically is a factor, but it doesn't contain an x, so it's not going to give us any information about values of x that will make this true. So, especially because 2 can't be equal to 0. So, I'm only going to set these factors equal to 0, the ones that have x. And we'll end up with, maybe you didn't even need to set up your equations to solve that one. You could see that you're going to end up with plus or minus 4. Next equation, we're going to be adding that 27 to both sides. All right, then we always check for GCF. So we're going to factor 3 out. We'll get x squared plus 6x plus 9 equals 0. Now this is a perfect square trinomial, so it'll factor as x plus 3 quantity squared equals 0. Right, so again, we could solve with square roots, but if we think about this, I just want to show you how the two methods compare. If we think about this as x plus 3 times x plus 3, right, if I set this factor equal to 0, it's going to be the same thing as setting this factor equal to 0, right? So I just know I'm going to have to end up setting x plus 3 equals to 0. And so when I do that, I'll end up with x is negative 3. All right, only 2 more to go, folks. Go ahead, try these out on your own. Tell me what happened. And then we will get started. All right, welcome back. So because when we're factoring, we want to have a positive a value, I am going to keep the x squared on the left-hand side and move everything else over. So we're looking for factors of negative 20. That adds to negative 1, so it's a little bit trickier because we do have different signs. We're going to have an x minus 5 and an x plus 4 equal to 0. So that gets me x is positive 5 and x is negative 4. So notice how I did not even show my work. I know, a math teacher not showing her work, right? But with these one-step equations, I'm sure your algebra teacher won't mind if you're not having to show all the steps of solving that one-step equation at this point in time. All right, so for this one, it is set equal to 0 in standard form. We have 6 times negative 5 gets us negative 30, and we're thinking about factors of negative 30 that add to 7. So factors of negative 30, I always start by writing my possible factor pairs, and I'll actually pause here because I noticed that negative 3 plus 10 is going to give me that negative or positive 7 that I'm looking for. So I'm going to split that apart, or uncombine that into like terms, minus 3x and plus 10x. This is the factoring by grouping method if you're curious. And now I'm going to factor something out, the GCF from these two, which will be 3x. So I'll end up with 2x minus 1. And we factor the GCF out here, which is going to be positive 5. And I'll end up with 2x minus 1 here. So this 2x minus 1 is like our last big GCF. I'm going to factor out to the beginning 2x minus 1. And then what's left over is 3x plus 5 equals 0. So now we can set those factors equal to 0. hands off. So this is going to get us a positive 1/2. And this is going to get us -5/3. All right, that's it, everybody.